Hey class, Mr. Moidian here. In this video, we're going to take a look at using the law of sines to find missing sides and angles of our triangle. So the first thing I'm going to notice when I see triangle XYZ is the fact that angle Y is missing, and finding angle Y should be pretty easy because we have two other angles of the triangle. So I find that angle Y is 83 degrees. Now this is not a right triangle, obviously, and as such we can't use traditional SOHCAHTOA, but what we can do is to use the law of sines, which says that the sine of an angle over its opposite side will be a constant ratio in any triangle. And what we have here is a set of values where we have angle Z, and we also have side length little z that sort of corresponds to it. So we have this like complete set. So for example, using our labeling system that we saw in the other video, if we call this side here, oops, let me go back to a small pen, lowercase x, and if we call this side over here lowercase y, what we can do is to recognize that we can use the law of sines to find this complete set. So let me illustrate what I mean by that. What we then know, therefore, is that these two are going to be linked together in the same way the two yellows are linked, and these two will be linked together in the same way those two yellows are linked. So what I can do, I'm going to use black ink here because it won't show up nicely in other colors. I'm going to say that the sine of 44 over 12, which is that yellow set, will equal the sine of 53 over x. X here being the little lowercase x because it's the opposite side to this one right here. So I can cross multiply. So if I do that, I get 12 sine 53 is equal to sine 44 times x, which is this little side right here. Now remember, sine 44 and sine 53 are just numbers that the calculator knows for us. So I'm going to divide both sides by sine 44, so as I can cancel out what that number is. And right away, I have x by itself. So ignore this triangle down here. We'll get to that later. From here, we can see 12 times sine 53 divided by sine 44 will give us our answer. So in the calculator here, I'm going to write that first to make sure I'm in degree mode, as you should double check that as well. We have 12 times sine 53. That's my numerator. I'm going to divide that answer by the sine of 44. And I find that side is approximately 13.796. So there's that side length. Excuse me, there's that side length. So all we're going to do is to repeat this process with the other set, which I have here in green, which is to say that sine of 44 over 12, again, this complete set here in yellow, will also equal the sine of 83 over its opposite side, which I've called y. So cross multiply these, give myself some more room. That's going to be 12 sine 83. So two separate problems here. 12 times sine 83 equals sine 44 times y. Divide both sides by sine 44 again. And in the calculator, I can find this value. It's going to be 12 sine 83 numerator divided by sine 44 in the denominator. And that gives me approximately 17.146. Not bad. So let's take a look at another example using the law of sines. And once we learn the law of cosines, which will come up in a couple days, we'll start to realize that not all problems can be tackled in the manner that we just saw. But when you have this complete pair of side and angle, then you can use the law of sines in a problem like this. Now, if we look at our sets here, we have angle n given, and we also have side length little n across from it. We have side length here little o, I suppose, and angle big O, which we don't know, but at least we know the side that goes with it. And then the least useful of these at the moment is this set right here. We don't know angle P, nor do we know side length little p across from it. So let me go back to my pen. We don't have this length right here, but I'll go ahead and label it as lowercase p. But because of that blue combination, I can at least say that the sine of 134 over 8.6 is going to help me in this problem. And since I don't know angle P or lowercase p there in green, that's kind of a dead end. But what I can do is to say that the sine of angle O, which is not a 0, just to be clear, that's the letter O, over 2.2 is going to be the same ratio based on the law of sines. And since I can find angle O, as you're about to see, this will make all the other pieces fall into place. So I cross multiply as usual. I will get 2.2 times the sine of 134 equals 8.6 times the sine of angle O. Divide both sides to get at least sine of O by itself. Ultimately, we want angle O. So divide by 8.6 over here. So on the left-hand side of my equal sign, I have a lot of math. That's 2.2 times the sine of 134. That's my numerator. And then I'm dividing that by 8.6. And that gives me that decimal right there, which is about 0.184. I'm going to use the exact value in just a minute, but it's that decimal. And the other side of the equal sign, I have that equaling sign of that missing angle that I don't know. Well, anytime we have a missing angle, in this case, sine of that angle, all we have to do is to use the appropriate tool to cancel out sine, or cosine or tangent, depending on what we have. In this case, it's sine. So the appropriate tool that will cancel out sine, of course, is the inverse of sine. So if I apply an inverse operation on sine to both sides of my equation, this sine cancels out, leaving me with just angle O, which of course is what we're looking for. And then over here, this says the inverse sine of that decimal. So I go second sine in the calculator, I go up here and grab that value. And hey, that's going to be about 10.6 degrees, which I can safely round to about 11 degrees. So angle O is approximately 11 degrees. So if I go back to my figure here, I can go ahead and label that, assuming I can get this to work. There we go. Now I could do the same process to find angle P, but since I now have two angles of my triangle, 180, take away 134, take away the 11 that we just found, hey, that must mean that this angle up here is 35 degrees. Now this picture clearly is not to scale, but again, the process here does work, as you'll see. Only one thing remaining, and that's to find side length little p. Well, again, that blue set of information, 134 and 8.6, unlocks all the rest. So I can close this problem by saying that the sine of 35, which we just found, over little p will equal that very same sine of 134 over 8.6. So at this point, we would cross multiply and divide. If you look at this problem right here carefully, you should be able to, based on the previous example, kind of see where this is going. I'm going to multiply in the calculator 8.6 times the sine of 35. That's one cross. The other cross is going to be p times the sine of 134. So if I just divide this number by the sine of 134, I should have the side length p, which should be 6.857. So that should be approximately 6.857. And there we go.